Welcome back to another episode. Today we're going to be talking about motors, specifically stepper motors. Motors. What are motors? They are little devices that take power in and transform that energy into motion, mechanical energy. So, for example, in this DC motor, we're using a motor through a small gearbox to turn the wheel, and this could be used to move a robot, for example. There is a different kind of motors, which are called servo motors. And a servo motor is directional. So it's not fully rotational. It goes to a certain direction. So let's say on a small remote-controlled car, you want to control the steering. A servo motor will be perfect for that because it's controlled to the steering, connected to the steering, and then it goes to a certain position that will rotate the front wheel, for example. And those don't fully rotate. So if I turn it to one direction, it stops actually at some point. It doesn't go further beyond. If I go the other way around, it also stops at 180 degrees from the other direction. So it's basically from 0 to 180, plus minus a little bit more. These are not extremely accurate. They're made for maker things typically, like an RC car or like a little hobby project. You're moving a robot, an arm robot, nothing industrial for these kind of servos. Now, how do these servos work? Internally, they are just a DC motor, just like this. There's a motor inside with a gearbox to slow down the motion. And there is a variable resistor, a potentiometer, that is connected to the output, basically where this is positioned. So the position of the motor will determine the resistance coming back. And there is a really small circuit inside that measures the resistance, and through that resistance, it knows where where it's positioned, and then it compensates. So if it's too much, it goes back a little bit more, or the other way around. Now, this is not very accurate, but it's for what it's intended for. It works quite well. Now, there are also different kind of servo motors, which are full rotation servo motors. These are servo motors just like this one, but these go all the way around. So they are perfect for a robotic application. Now, the difference between this servo motor and the regular motor, this one doesn't have a feedback. This one has feedback. That variable resistor that we talked about, it's there, somewhat there, it's faked. So when you set the position, you're actually setting the speed. So when you set the position to the middle, which is 90 degrees, the motors don't move. When you set it to, let's say, all the way 180, the motors go clockwise, or the other way around. And then when you set it to, let's say, 0 degrees, the motor will be going the other way around. And this is how you can generate motion. So let me show you this demo really quick. So go in one direction, going forward, and go in the other direction. Now, enough with these motors. What we're talking about today is actually stepper motors, which are very, very important in industrial applications and in anything complex that you want to do. Let's say you want to build a CNC machine or a 3D printer or a laser cutter. Anything that requires a motor to move at precision, that would be a stepper motor. As you can see here, we have several stepper motors, from really small one to a very large one. On top, they may not look very different, but if you compare the sides, they are quite a bit different. Now, stepper motors work very differently than regular motors. So we said servo motor is basically a DC motor that has some kind of feedback. DC motor is a free running motor. You may add gearbox to slow it down, but doesn't mean you know how many rotations that motor has incurred. Now you can add other things to count, but that doesn't change the fact that this is a DC motor. Stepper motors work very differently. They run in steps. So every time you move the motor, it doesn't rotate. It goes from one step to another. And this works through, there are magnets and coils inside. And when you energize the coils, if they are different polarities, as you know, magnets, if you have north and south pole magnets, they attract. If they are the same polarity, they repel. The same theory works inside a stepper motor. So there are magnets in the middle connected to the center of core of the stepper motors, and then on the side there are coils, and there are two sets of them. They are like 90 degrees from each other, and then depending on which coils you energize, you're either pulling or pushing the internal magnet through these coils that we have internally. To control steppers, those coils inside, they need a lot of amperage and a lot of power normally, more than a microcontroller can handle. So you can really just connect a pin from a microcontroller to a stepper motor. You would need to have some kind of transistor that handles that power. So we talked about transistors before in a different tech talk. The circuit will be controlling the transistor or some circuitry, and that circuitry takes much higher power and energy current from like a power source and uses that to control the coils. Now you could do that through a microcontroller, but this would be too much work and it's not recommended. Anybody building something decent, usually like a laser machine or a 3D printer, they would have a controller. And in this example, I have a controller right here. Those are inexpensive. You can get them off eBay, let's say, pretty cheap in a lot of places online. Those handle a lot of amperage, and they are optically isolated, meaning the connections that go to your circuit are optically, there's just light going between this side of the circuit and what's going on the motors. This is very important to protect your circuitry. So something happens, pulses, noise, these generate a lot of spikes on power. This doesn't make it back to your circuit. You would have a strong power supply that, depending on the size of your motor or motors, and then you would have that coming in as an input. So in this example, I have 24 volts coming into the circuit. And then you would have the wires that are going to your stepper motor. And in this example, I have the stepper motor. So the way this works is pretty simple. If you look here at the diagram that we have on top, there are switches on the side. And they're numbered switch 1, 2, 3, and they're numbered 1, 2, 3. And over here, you can see like switch 1, 2, switch 3. And these switches do change the way this controller works. So for example, if we look over here, we can see that if we set the switches to off 0, off 1, 1, 1, so off, on, the motor will go around full rotation. Every full rotation is 400 pulses. So if we set it to this configuration, and then there is a pulse input over here, all I have to do is pulse it. So every time I pulse it, the motor moves a step. Remember, this is not used to move things. It's used to go to a specific location. Like you have a CNC machine, and you're moving it to you're moving the x-axis in a certain direction. Now you say you want to move that much distance, and then through how many pulses? Now this is 400. It's not very accurate. You can go all the way down and have thousands of steps per rotation. So it can get really, really accurate. Now for the sake of this demo, I have it set to 40 because it's easy for me. So the BrainPad, since it's easy to use the BrainPad with the IOs over here, I'm using the BrainPad. Let me connect it really quick and show you the demo, and then I'll explain it more. So here's a little battery to power up the BrainPad. So keep in mind now, BrainPad processor power has nothing to do with the power going to the motors. And that's very good, because the BrainPad uses low power, it's safe for the BrainPad, it doesn't cause damage. And then the motors that generate noise on the signals and require higher voltage are powered separately by a separate power supply. So power up the BrainPad. So what my program is doing, you see over here, there's pulse and direction. So what I'm doing in this program is generating exactly 400 pulses, and then reversing direction and generating another 400 pulses. And if you look, the motor is going exactly to the same location every single time. Every single time. This is what I'm talking about when I say this is what you need in an industrial environment for a CNC machine 3D printer. Because this is the only way you can control where the stepper goes. Now, it can get a little bit complicated than that, because what if there is too much force on the motor and it skipped a step? I'm not going to cover that right now. But for typical use, the stepper motor, 400 pulse, it will go, if you run this for a year, it will always go back and forth in the exact same location. Every 400 pulses, it's a full cycle. Now I have changed my program, so if I press the center button, it no longer reverses directions. So For example, now I have a CNC machine or 3D printer, and it's going to somewhere, some location, and that will be going full location. And then you can stop it at exactly where you want it to stop. So now I have stopped it randomly, I raised the button, and wherever it stopped at, it's gonna keep going back and forth indefinitely to the exact same spot. Now the other button I have programmed over here, it goes 200 pulses instead of 400 pulses. And as you can see, it's going exactly half. So every time it goes back to the same spot here. Half rotation, half rotation. Now I'm gonna change the switches also on the controller to show you what happens. So I'm gonna change it to the next step up, which is 800 pulses instead of 400. So I'm gonna switch, it says here switch number 5. So I'm gonna switch this one off and this one on. And I'm gonna reset the power. Now it's going halfway across. Before it was going all the way around, because now I'm still sending 400 pulses, but to the controller right now, the rotation is 800 pulses, so 400 pulses will be halfway across. So if I press this button, which now sends 200 pulses, it's gonna go only 25%, only quarter way around the circle. That's basically it. So I recommend to use a stepper controller, to use your not to use a microcontroller to control steppers. That would be just too much work. This is much easier and safer for your circuit. It's optically isolated, and very simply you have pulse and direction. The other switches over here control how many amps go into the motor, and the higher the amperage, the larger the motor is, the stronger it is, the more power supply you need. But that's basically it for stepper motor. I hope you enjoyed this video, and we'll see you next week.